Okay, so this is kind of an extension of radicals, but there is such a thing, I call it the golden rule for math, but you cannot have any radicals in your denominator, so your final answer. So if we look at number 1, obviously it has a radical in its denominator, but I know what the cube root of 8 is. The cube root of 8 is 2. Now, the top can have a radical in it. Obviously, I want to clean it up if I can, and there are no cubes in 4, so he's just going to be the cube root of 4. You cannot reduce these two. One is under the root and one is out of the root. So this would be your final answer. And notice I do not have a root in my denominator. So we go to number 2. Now number 2 has one big root. It's the same thing as 2 separate roots. So you can think about it either way. Again, remember the golden rule, no roots in the denominator. So always go the denominator first. And the square root of 9 is 3. So that kind of takes care of that for me. 20 has got a square. It's 4 times 5. So this would be 2 root 5. So it's cleaned up, it's reduced, and there's no root in the denominator. Sometimes, like when you get to number 4, like 6 is not a perfect square, but because this is a monomial over a monomial, it also happens to divide up. So root 18 divided by root 6 is going to give me a root 3. 12 and 10 I can both reduce by 2. And now I have a cleaned up fraction with no root in the denominator. It was not a perfect root, but it did divide up. Number 5 is the same thing. I can divide up the outside and the inside, but then remember you can square root that 4 and get a 2, so that's actually going to become a 20. Now, so those are the easier ones. Now when you get to a problem like number 6, number 1, the root in the bottom is not a perfect square, and it does not divide up. There's not even a root on the top for it to divide into. So this is when we're going to multiply by something to make it, to force it to become a perfect square. And I know that I can turn a 3 into a 9. So my goal is a 9. So now I think, well, what do I need to multiply by for it to become a 9? Well, it needs another 3. So I'm going to multiply by root 3 over root 3. Now, the reason that's legal is because when you have something over the same something, that's really just a big fat 1. So I'm really just multiplying by 1. Now, watch what this does. This is going to give me 5 root 3 on the top. And then on the bottom, it's going to give me 2 root 9, which is now a perfect square. That's a 3, and 3 times 2 is 6. And 5 root 3 is completely simplified, and I can't reduce anything. So again, I'm trying to get good with the golden rule and not have any roots in the denominator. Okay, so let's look at number 7. And again, I start straight on the bottom. 2 is not a perfect square. It does not divide into the 5, so I'm kind of stuck with it. So I need to multiply it by something. I'm going to multiply it by another root 2, top and bottom, because that's what makes it legal. So let's see what this gives me. This gives me 6 root 10 on the top and 2 root 4 on the bottom. 4 is a perfect square. Square root of 4 is 2. 2 times 2 is 4. And 10 has no squares in it. So 6 root 10. And then the only other thing I can do is I can reduce my 6 and my 4. Now, I cannot touch the 10 because it's under the root. It's sort of like in jail. It can't be touched. So that's going to give me 3 over 2, and the root 10 just kind of stays put. Number 8, I can multiply by a root 8. Well, no, I don't have to multiply by root 8. I don't have to go all the way to 64. I can go to 16. So I'm going to multiply by root 2 over root 2. And that's going to give me 5 root 6 over 7 root 16. And that's a 4 times 7 is 28. And 6 doesn't have any squares in it. And I can't reduce. So I need you to be able to handle something like a root that we deal with a lot in pre-calculus is like 3 over root 2. And I need you to look at that and say, okay, well, I'm going to multiply by root 2 over root 2. and that's going to give me 3 root 2 over, and then root 2 times root 2 is root 4, and the square root of 4 is 2. That's something that we're going to do like on a daily basis. So I need you to be super comfortable with multiplying it by a ratio that gives you 1. Again, that's what makes it legal. But multiplying by something that will make the denominator perfect square. So let me just do another one real quick. So if I had like 5 over root, I don't know, we'll go 5. 5 over root 5. So I can't have a root in the bottom, but I know that I can turn that 5 into a 25, which would be a perfect square. So I'm going to multiply by root 5 over root 5. So that gives me 5 root 5 on the top, and that gives me a root 25 on the bottom, and root 25 is 5. And then when you get here, the 5s that are both outside can cancel. Okay, so this is the goal, and this is what you need to multiply by to turn that into the goal. While we're here talking about being able to reduce this, I want to make sure that you know that if you had this, you cannot reduce these two 5s. Once you put a plus sign with this and this becomes a polynomial, not a monomial, then you can't reduce. But if I had like, let's see, 2 plus 6 root 3 over 8. So do you see how every single term, again, that's on the outside, can reduce by 2? So I can make this 1 plus 3 root 3 over 4. So all I did, I took all my outside numbers and reduced them by 2 because they can. But if I had this or this, and they couldn't all reduce, so he's a 2, he's a 1, he's an 8, they don't all have something in common. He's a 2, he's a 5, and he's an 8. They don't all have something in common. I cannot touch them. I cannot reduce it. The only way I can do it is if they can all reduce by the same number. That's what makes it legal. And that is a huge careless mistake, algebra mistake in pre-cal. So the sooner you learn